Hi, this is Branton Pay, and this is for my senior project on Milestone 3 on completing the beveling pipes project. Right behind me you can see we've got the motor and the machine, and let's take a look at that. We've got the bit. So for my third milestone, I'm doing the PLC programming and adding all of the safety and all of the programming required to complete this project. So all of the programming to this point is completed for everything that we want right now. We may add more to it in the near future. For right now, we have a lot of safety features as well as how things are running. Let's look at the code. You can see we've got these different networks. Everything is live right now. We have the start and stop, which will start the motor and stop it. You can see that these are not active right now. And then we also have this will turn on the contactor, which will run the motor. This is for if there's no pipe in the machine. This is the pipe has begun to be beveled. This is saying that the pipe is done once the current or voltage is in the correct region, from 4.6 volts to 4.75 volts. And you can see that is working in Cameron's video. This is where we take the input in as a double integer and we convert it out to a real number, and from that real number we're dividing by this large number to get it in the range that we want it. It's fluctuating a bit right now, but it's about 0, and then we're moving that value to other places, which are these these greater than or less than logic to make things work. We also have the same converter for the motor current, reading the current coming out of the motor, and this is sensing to see if there's a bad bit or the motor is bad for the next one. And then if the bit is bad or the motor is bad, we have these two sections. I will toggle this on. There will be a light that will toggle on and off. This is that light. It'll be repeating, and this is what turns this off and repeats it. So let's look at the PLC. You can see that light number 5 is turning on and off every second. 1 second on, 1 second off. And I can turn that bit off, and then they'll stay off. We're looking at this live. Let's look at network 11. So this is sensing for the if the motor is running. So if any of these things are live, then the motor is running, and there's a caution light that will go on. We'll see that that's working. If there's any light, so for the caution, so this is setting the bit that there is a caution and that it needs to be going. So if the caution is lit or the motor contactor is on, then the caution light will be running. And then sensing for overload. If there is any overload, it will go to the next bit or the next line, which will do an emergency shutoff, and then that emergency shutoff light will stay on until the stop switch resets everything. And then so this is to make sure that the motor is running. Now let's turn that on. You can see we have a light right here for with the motor is on or off, and we can also read the current. We can also read the current through this current transformer right here, and it is hooked up to that meter, and this is our contactor. So we're live right now. If I flip this switch, then the motor will run. That second switch turns it off. Now let's look at the code. You can see the code here, and so when I turn the motor on, right now, you can see that those lit up green and that those lights were going. We can also look at the light right here. And that light's working. So the programming for this project has been completed, and any other things will be added as necessary to improve on safety and functionality as we get more values also from the voltage from the motor to find out what exactly, when the motor has gone bad or the bit has gone bad. Testing needs to be done on full loads to actually bevel pipes. At this point we still need the guard and the faceplate right here to make sure there's a stop plate for the pipe. And that's where we are, and thank you for listening.